Hi guys, welcome to Unit 10 Lesson 4 notes on adding and subtracting radical expressions. By the end of the day, you will be able to add and subtract radical expressions. So let's jump right in with a review. Let's simplify each of these expressions first. Here we have 5x plus 3x. So our strategy here is you'll see they both have an x in common, so we're going to factor out that x, giving us 5 plus 3, both of those, times x. And 5 plus 3 is 8, so we have 8x. All set. In our next expression, we're going to do something very, very similar, but instead of factoring out an x, we'll factor out a y. So here, each of these terms have a y in common. That makes them like terms. So let's get that y out of there, leaving us with 8 minus 2 times y, and 8 minus 2 is 6. So this is equal to 6y. Now that we have both of those, we're going to put those together following those same steps. So here you'll see again we have x's in common. So we're going to factor the x out, leaving us with just 7 plus 2 times x. And then we have negative 8 plus 5 times y. This is because I had factored out a y from each of those terms, and that gives us a minus 8 plus 5. So in that parentheses, 7 plus 2 is 9, so we have 9x plus, and then negative 8 plus 5 is negative 3y. If you would rather write it like 9x minus 3y, that's fine as well. Now you'll notice that that is much simpler than what we started with. That's our idea today. Today we will be using the distributive property, but backwards, to help us simplify rational expressions. So instead of starting out up here with 5 plus 3x and distributing x to each of our terms, that's what we started with. Instead, we undo that process to simplify our expression. So we're going to do that, but with radical expressions. So let's take a look. Here down here in activity 1, number 4, we have 5 times the square root of 10 plus 3 times the square root of 10. Now they each have a square root of 10 in common. So we're going to follow the same steps that we did up here. We're going to factor out that square root of 10. So we have a square root of 10 all at the end, and that leaves us with 5 plus 3. So we have 5 plus 3 times the square root of 10, and then we can combine those into 8 times the square root of 10, and we're all set. That's it. Let's do another one. So in activity 5, or problem 5 in activity 1, this time they have a square root of 3 in common. So what should we do? We're going to factor something out. What will we factor out? Let's factor out here. We factor out, I'll write that down. So here, what are we going to factor out? Let's factor out a square root of 3. So taking the square root of 3 from our first term leaves us with just 8. Taking our square root of 3 from our second term leaves us with a minus 2. So now we have 8 minus 2 times the square root of 3. Last time I checked, 8 minus 2 is 6. So we have times the square root of 3. And that's it. Oh hey, this should look awful familiar. We're following those same patterns. Here we had 5 times something plus 3 times something. That gave us 8 times that something. Here our something is the square root of 10. So 5 square roots of 10 plus 3 square roots of 10 gives us 8 square roots of 10. Similarly, we found that 8 of something minus 2 of that same thing is going to give us 6 of that thing. Similarly, we have 8 times the square root of 3 minus 2 square roots of 3, and that gave us 6 square roots of 3. It's the same kind of thing, but now we know that x is the square root of 10. Cool, huh? It's like, math is fun. Totally. That's good. But so far, we've been using problems with the same radicand. It's been the same thing under our square root. So what happens when they're different? So before we do, let's talk about some definitions real quick. So we say radicals are, let's see, I'm gonna use purple. Like radicals are radicals with the same radicand. Now you remember that a radicand is the thing underneath the square root. So if you have an expression like the square root of, 52, it's not even simplified. The radicand is what is underneath your radical. And then an unlike radical, an unlike radical are radicals with different radicands. It would help if I spelled radicands correctly, huh? With different radicands. So like radicals, for example, are things like 5 rad 2 and 8 rad 2. But unlike radicals would be, 5 rad 2 and, 8 rad 7 or something. These are not like radicals. They are unlike radicals because their radicands are different. These are like radicals because they have the same thing under the square root. So let's get into our key idea of the day, talking about adding and subtracting radical expressions. What you want to do first you want to simplify all the radical expressions as best you can. And then you'll combine like radicals. We have 3 examples. So we're going to simplify, and then we're going to combine. So let's start out with number 6. So I see this square root of 27, and I know that 27 can be factored. 27 can be factored into 9 times 3, and 3 is prime, but 9 can be factored into 3 times 3. Because 9 is a perfect square, I'm going to want to leave that in my factorization under my radical. So we've got 4 times the square root of, let's use 9 times 3, because 27 is 9 times 3. In fact, I want to change my yellow color. Is that okay? I want to make it green. So I know 27 is equal to 9 times 3. Cool. And I left 9 open because 9 is 3 squared. In a very similar process, I'm going to simplify the square root of 12 to be the square root of 4 times 3. Now let's keep going. I can break these guys up, so I have the square root of 4 times the square root of 9 times the square root of 3 minus 5 times the square root of 4 times the square root of 3. Now the reason I broke 27 and 12 into these factors is because they are squares. 9, we talked about, is 3 squared, and 4 is 2 squared. So I'm going to use those facts to help me simplify this radical. So like I said, the square root of 9 is 3. Sweet. The square root of 3 is the square root of 3, 5, and the square root of 4 is 2. So I can simplify those radicals because they are perfect squares, leaving us with the square root of 3. We can clean this up a little bit. 4 times 3 is 12 times the square root of 3. 5 times 2 is 10 times the square root of 3. And now look, we have 2 like radicals. The square root of 3, and the square root of 3. So we can undistribute that square root of 3 out, leaving us with just 12 minus 10. Now what is 12 minus 10? It's 2. So we're left with 2 times the square root of 3. Little hard to believe, huh? This whole expression, that's equal to, oh yeah, 2 times the square root of 3. Cool, done. So again, we started out by simplifying our radicals. We simplified this to 12 rad 3. And we simplified 5 times square root of 12. Oh, we simplified that down to 10 rad 3. Because those were like radicals, we could combine them into one simple radical expression. Let's do another one. Here in number 7, we can clean up the square root of 18 by breaking it up to 9 times 2. And same thing. This square root of 50 is not simplified because 50 has a perfect square factor in it. It's 25. So now that we've broken up 18 into 9 times 2 and 50 into 25 times 2, we can simplify those radicals by splitting them up. So now that we broke those up, we can simplify these two radicals because the square root of 9 is 3 and the square root of 25 rather, is 5. So that gives us 7 times 3 times the square root of 2 plus 3 times 5 times the square root of 2. Again, we factored 18 into 9 times 2 because 9 has a square root of 3. And we factored 50 into 25 times 2 because the square root of 25 is 5. Now we can clean those up. 7 times 3 is 21. And 3 times 5 is 15. We're almost there. Now we have two like radicals. These are like radicals because they have the same number in their radicand. That is 2. So we can distribute a square root of 2 out from each of these terms, giving us 21 plus 15 times the square root of 2. And 21 plus 15 is 36. So we have 36 times the square root of 2 as our final answer. Great, we'll do one more. Because here we were left with one term. They had the same radical. Oh, no. Here we're also left with one term. They had the same. We have one radical expression, one radicand here, because these were like radicals. Spoiler alert, we're not going to have like radicals here, so I'm going to show you what to do. Okay. Right now we already don't have like radicals, but that's nothing new to us. We already started out with not like radicals, with unlike radicals. So let's, again, follow our steps, simplify the radicals, and combine like radicals. Combine like radicals, because we like them, because they're the same. Okay, here we go. So we can simplify each radical, because 8 is equal to 4 times 2. And 27 is equal to 9 times 3. So again, we looked at, wrong color, we looked at 8, that's equal to 4 times 2, so those are equal. And then 27 is equal to 9 times 3. Now I picked those factorizations because 4 is a perfect square, and so is 9. The square root of 4 is 2, and the square root of 9 is 3. Oh, just kidding. Went too fast. Square root of 9 is 3. So I can simplify the square root of 9 as 3, and I can simplify the square root of 4 as 2. Now let's combine those. 3 times 2 is 6. 3 times 3 is 9. Alrighty, now notice these radicands are different. The square root of 2 and the square root of 3 are different, so we cannot combine them. This is our final answer. It might not look much simpler to you, but it is simpler because we don't have perfect square factors in our radicands. So there you have it. Our 2 steps today were to simplify radical expressions and combine like radicals, because really that's simplifying, but more, and again and again. I hope you enjoy your homework. I hope it's radical. You guys are super. Have a great time.